Welcome back to our study of networks and distributed systems based on the textbook by Jim Couros and Keith Ross entitled Computer Networking, a Top-Down Approach. We have been discussing medium access control, and we will pick up where we left off. This is lesson 7 in our discussion of the link layer of the TCP/IP model. Let's pick up where we left off. We have just learned about 3 broad classes of multiple access protocols: channel partitioning protocols, random access protocols, and taking turns protocols. A cable access network will make an excellent case study here because we'll find aspects of each of these 3 classes of multiple access protocols with the cable access network. A cable access network typically connects several thousand residential modems to a cable modem termination system at the cable network head end. The data over cable service interface specifications, DOCSIS, specifies the cable data network architecture and its protocols. DOCSIS uses frequency division multiplexing to divide downstream network segments and upstream network segments into multiple frequency channels. Each downstream channel is 6 MHz wide with a maximum throughput of approximately 40 megabits per channel, although this data rate is seldom seen at the cable modem in practice. Each upstream channel has a maximum channel width of 6.4 MHz and a maximum upstream throughput of approximately 30 megabits per second. Each upstream and downstream channel is a broadcast channel. Frames transmitted on the downstream channel by the cable modem termination system are received by all cable modems receiving that channel. Since there's just a single cable modem termination system transmitting into the downstream channel, there is no multiple access problem. The upstream direction, however, is much more interesting and much more technically challenging, since multiple cable modems share the same upstream channel or frequency to the cable modem termination system, and collisions can potentially occur. As illustrated here in Figure 5.14, each upstream channel is divided into intervals of time, similar to time division multiplexing, each containing a sequence of mini-slots during which cable modems can transmit to the cable modem termination system. The cable modem termination system explicitly grants permission to individual cable modems to transmit during specific mini-slots. The cable modem termination system accomplishes this by sending a control message, known as an MAP message, on a downstream channel to specify which cable modem with data to send can transmit during which mini-slot for the interval of time specified in the control message. Since mini-slots are explicitly allocated to cable modems, the cable modem termination system can ensure there are no colliding transmissions during a mini-slot. But how does the cable modem termination system know which cable modems have data to send in the first place? This is accomplished by having cable modems send mini-slot request frames to the cable modem termination system during a special set of interval mini-slots that are dedicated for this purpose, as shown in Figure 5.14. These mini-slot request frames are transmitted in a random access manner and may collide with each other. A cable modem can neither sense whether the upstream channel is busy nor detect collisions. Instead, the cable modem infers that its mini-slot request frame experienced a collision if it does not receive a response to the requested allocation in the next downstream control message. When a collision is inferred, a cable modem uses binary exponential backoff to defer the retransmission of its mini-slot request frame to a future time slot. When there is little traffic on the upstream channel, a cable modem may actually transmit data frames during slots normally assigned for mini-slot request frames and therefore avoid having to wait for a mini-slot assignment. A cable access network serves as a terrific example of multiple access protocols in action: frequency division multiplexing, time division multiplexing, random access, and centrally allocated time slots, all within one network. Now that concludes our discussion of broadcast networks and multiple access protocols. We are about to go into a discussion of switched local networks, local area networks. And so before starting that, let's break right here so that you can gather all your thoughts together about the subjects we've been talking about for the last several lessons and update your study guide. And when you're done, come on back and we will start lesson 8.